Okay. 2016, question 1, Calculus AB. Part A, I'm just going to start with Part A, and then we can look back at the fine details as we go along. Part A is asking you to estimate R prime of 2, and I'm trying to get this to, there we go. Often, Part A does ask you with a table of values to basically throw down a slope formula. You have a table representing R, you're estimating R prime at 2. 2 is the t-coordinate between 1 and 3. That means you have to use the nearest 2 points and do a slope formula on those nearest 2 points. If for some reason 2 was one of the t-coordinates, then there are technically 3 slopes you're allowed to use, but you only need to use one of them. And the 3 slopes would be the 2 surrounding or its data point with one of its 2 closest data points. So, also when it says show the work that leads to your answer, they want to see the formula you're using. So you're saying R prime of 2 is approximately R of 3 minus R of 1 over 3 minus 1. So you're telling them this is the slope formula I'm using, and then you can go ahead and just throw those numbers down. So at that point, you can say that that is equal to 950 minus 1190 over, and you can write 3 minus 1 or 2, but know that you can stop here unless you feel like you want to take the risk of subtracting and dividing by 2. You do have a calculator, so hey. Now, it says include or indicate units of measure. So you want to look at if it's R prime with respect to t, then you're looking at the units of the R of t divided by the units of t. So it's liters per hour per hour. And you can write it with the words per, P-E-R, and go liters per hour, just anything that means this. All right. That was worth a total of 2 points, one for the estimate and one for having the correct units. You can also write liters per hour square if you don't want to write it. Let me just write that down. You can write it that way as well. All right. Part B. Often on a table of values, Part B is estimating a definite integral using either rectangles or trapezoids. This one is using rectangles, but my advice is before you start into the estimation, write down the integral that you are solving. Because often they ask you for something that's bigger than just the integral itself. Now this says you're going to use a left Riemann sum with the 4 subintervals indicated by the data in the table to estimate the total amount of water removed from the tank during the 8 hours. So from time 0 to time 8, 4 subintervals indicated by the table mean you're going to look at a delta t of 1 in between these 2 t coordinates, a delta t of 2 from 1 to 3. From 3 to 6, you're dealing with a delta t of 3, and from 6 to 8, you're dealing with a delta t of 2. So those are your widths. And then if it's a left Riemann sum, then you're going to use the left R value. So for my delta t is 1, I'll use the 1340. For my delta t is 2, So I'm using the left t coordinates value with each of those individuals. So now what I'm going to do is I'm going to write down the integral that solves what it is asking me to estimate. I am estimating the total amount of water removed from the tank. And as far as water removed, it is solely just the R of t function. You're not including the W function for pumping in because it's only total amount removed. So what you're going to do is you're going to say, I am solving, or should I say estimating, the integral of R of t dt from time 0 to time 8, and then saying that that is approximately. And now's when you're going to throw in your left Riemann sum. I've got my delta t of 1 multiplied by my y value, 1340. And then you're just simply writing it all down. My delta t of 2 goes with 1190. And then delta t of 3 goes with 950. And my final delta t of 2 goes with the 740. You can leave your answer written this way, but you do have a calculator, but sometimes you type the wrong numbers. And this, in this format, is worth the full points of you to solve the Riemann sum. Now, it goes on and asks, is this an overestimate or an underestimate of the total amount of water removed? What you're going to do to determine over or underestimate is first identify for yourself who the integrand is. When it comes to a left or right Riemann sum, is it an over or an underestimate? It is whether your integrand is increasing or decreasing. And I'm drawing you two different concavities for increasing and two different concavities for decreasing, because I want to show you that the concavity isn't going to determine it. It's whether the slope of the integrand is positive or negative. Because as you're integrating the R function using a left Riemann sum, if I draw little left rectangles, I can see that it's not concavity that determines that it's underneath. It's the fact that it's heading up. And when I draw a left-ended rectangle on my positive slopes, the concavity doesn't affect the fact that it's above. It's the decreasing. So if I'm dealing with R prime being positive, then it's going to be an underestimate. But if I'm dealing with R prime being negative, it's an overestimate. Now I've got to figure out which of the two is it, and they have to be very specific when it comes to a table. I can't just assume that the pattern I see in the table is going to just stay being the pattern. So I've got to read the words to figure out what's going on with R prime. Is it positive, negative, or is R increasing, decreasing? So it says, water is removed from the tank at a rate modeled by R of t liters per hour, where R is differentiable and decreasing. Cha-ching, found it. So, darn it, I just threw my pen. I got so excited about that. There we go, found it. So, this says R is decreasing. So you need to say that because R is decreasing, and then this was a left, yes, a left Riemann sum is an underestimate. of the actual value. Now, maybe instead of saying R is decreasing, you say R prime is less than 0. But the reason I wrote because R is decreasing is because this is how the information was presented to you. So you are stating that you know this information was presented to you and that this is the information that confirms the underestimate. If you look at the way the AP test wrote the answers, they said this is an overestimate since R is a decreasing function. And that's all they said. And I would assume that if you said R prime is less than 0 instead of R is decreasing, that you still get the full credit because it's saying the same thing. But I just want to express to you that by you restating something that was said in the middle of a whole bunch of words, you are saying, I understand that this is the piece of information that determines the result. And so that's a good thing to do. And then the left Riemann sum and getting the correct numbers was worth 2 points. I will say that it is good form when you are doing an estimate. Where did the other problem go? When I did the slope, when I estimated the slope, where did I put that? Oh, well, I can't find it. It's valuable for you to explain where these numbers came from. So I recommend that you do that, that you say that this is approximately, and then explain that you are doing 1 minus 0 multiplied by R of 0 plus 3 minus 1 times R of 1, and so on. And let me just throw out real quick that this is how they showed the work. They didn't even do the subtraction. They just wrote the widths, but did say specifically that they were using R of 0, R of 1, R of 3, R of 6, just for clarification. All right, then let's move on to the next part. And actually, I should make sure that I said everything. Use the left Riemann sum. Okay, yes. All right, part C. Here we go. They want you to use your answer from part B to find an estimate of the total amount of water in the tank to the nearest liter at the end of 8 hours. Now, if the answer you got to part B was incorrect, but you have an answer and you use that answer correctly, you can still get full credit in part C. Know that. So you are given that water is being pumped into the tank at a particular rate. I'm going to erase because I've got too much stuff all over the place. Okay. Realize that when you integrated R, you were looking at removing. But W is water being pumped into the tank and the rate at which it is being pumped in. I'm going to color code actually. Okay, so we've got yellow highlight is rate in, blue highlight is rate out. You also need to know how much water is in the tank at some point in time. That is given to you here. So again, we are trying to estimate the total amount of water in the tank at the end of 8 hours. We're going to start with the 50,000 liters at time 0. Then we are going to add to that how much was pumped in. You'll be able to integrate the W of T function, which is the rate that water is being pumped into the tank from time 0 to time 8. This is a calculator problem, so you're going to let your calculator solve that particular integral. You're going to then subtract from that whatever your estimate was in part B. Now, if you didn't simplify down to a nice number, what you might want to do is just take your giant estimate. Let me bring this over to explain what I'm referring to. You can take this, I'm trying to show just one of these lines. I'm trying to show this line. You can take this estimate and just say equal to, pick a letter that isn't in the problem, and then you can use that letter, refer to it in part C. But then again, at the same time, you've got a calculator, so it's probably not too much to sit there. It might be easier to just plug it in your calculator, get the number. Anyway, then you'll subtract whatever that approximation is. But it did say round to the nearest liter, so make sure that you do round to the nearest liter. All right, then let's move on to part D. Oh, is there a time T when? At that moment, when I read, is there a time T when? Let me highlight that. That screams to me that I'm either going to need to use mean value theorem or intermediate value theorem. Just that phrase right there. And they often will ask those value theorems in a table of values problem. So let's see what it's asking us to determine. Is there a time when the rate at which the water being pumped into the tank is the same as the rate at which the water is being removed from the tank, and you need to explain why or why not? So the way it's worded, you're thinking, is there a time when W of T is equal to R of T? But let me tell you what you want to do always when it comes to either IVT or MVT. You want to take that equation and make one side 0. That is what's going to get you through some of these IVT, MVT problems. Now I'm going to read it again. For a time between 0 and 8, is there a time when the rate at which the water is being pumped into the tank is the same as the rate at which water is being removed? Both of them are rates. They're asking if they are ever equal. This is intermediate value theorem. In order for you to explain your reasoning, you need to make sure that you state that you are using intermediate value theorem. You also need to state the conditions of intermediate value theorem. And those conditions are that you have a continuous function over a closed interval. So what you're going to need to say is that the function W minus R is continuous over the interval from 0 to 8, that closed interval. Now, how do you know it's continuous? You know that w on its own is continuous because it's an exponential function, and exponential functions are continuous. The only reason you know r is continuous is because of this word being used. It told you that r is a differentiable function. That means not only is r differentiable, but it's automatically continuous because it has to be continuous in order to be differentiable. So if you want, you can, explain where you got that from, but you don't need to. All you need to do is state as a matter of fact that you know that this is continuous. Because there are properties of continuity that say if you have two continuous functions and you add or subtract them, the result is also continuous, but you don't need to go into that detail. Now, with that said, you're going to look at what is the subtraction at 0 and what is the subtraction at time 8. For the w function, you're going to let your calculator give you an answer. You're going to plug into this t, a 0 and an 8, and you're going to write that number down. And let me see if, the free response exam didn't even write it down. Or did it? Nope. It didn't even write down what those numbers were. But I'll just say, put in a calculator, get those numbers. Then when it comes to r, you have these numbers and you need to write those down. But when I'm looking at the way the AP test wrote its answers, all they did was determine which of these was positive and which one was negative, because that's what intermediate value theorem cares about. And so if you compare the calculator number you got for w of 0 with 1340, you are going to find that the w function is bigger. And if the w function is bigger, then this is positive. Then you're going to look at, in your calculator, plugging 8 into the t and comparing it to 700. This time, the r function is bigger. So this is negative. With the intermediate value theorem, you just need to state that there is some number for which at one of the times this function is greater than that number, and this same function at another endpoint is less than that number. That's all intermediate value theorem needs. It just needs that your function is continuous over the closed interval, state the number that you are saying it has to equal, and then show that at one endpoint you've got positive, at the other endpoint you have negative, boom. And then you can just say, therefore, the intermediate value theorem guarantees at least one time between 0 and 8 for which w minus r is 0, which is when they will be equal. And I'll just show you what they have written, and then this problem will be done. And I'm going to